introduction. So welcome also from my side to the CAN conference. Well, CANXL is emerging more and more, and in the past few months I read sometimes about CANXL. Well, it's the guardian of the old world. So I was somehow amused about that, but of course when we think about Automotive Ethernet, that brings IP communication and internet into cars, well, it somehow seems to be old-fashioned. Is it really old-fashioned? Well, I'd like to talk now about how we can implement and apply IP concepts also on CANXL. What I experienced recently is that we see a certain consolidation towards Ethernet and CAN communication in in-vehicle networks. So that means that protocols like FlexRay and MOST, so these use cases can basically also be covered by CANXL and Ethernet. Now let's have a look on what this consolidation means for the 10 megabit domain in automotive networks. Now, Ethernet today uses bit rates between 100 megabit and 1 gigabit for use cases such as ADAS or connectivity, while for classical embedded control use cases like engine management, still CAN or CAN-FD are widely used, providing bit rates up to 5 megabits. But what about a 10 megabit domain? There are still also many use cases located in that domain. And there are two solutions available today or upcoming that could occupy that domain. One is Ethernet based, called 10BASE-10.1s, and the other solution, of course, is CANXL. Now let's have a closer look on those use cases. As I already mentioned, you can either realize a network in the 10 megabit domain using 10BASE-T1S, or you can use CANXL. Well, what we have to consider is how the communication is realized. And when we talk about CAN, usually we talk about a signal-based communication. That means you have signals of fixed size that are statically mapped to a CAN frame. In Automotive Ethernet, usually you work service-oriented. For that, a scalable service-oriented middleware over IP, short sum IP, is used. And here you have dynamic data structures because you have use cases like sensor fusion or streaming, and that means that the size of the data is determined at runtime of the application. And this also means that the data are not mapped anymore statically to a frame, but are serialized dynamically. Now, if CANXL needs to cover all those use cases in the 10 megabit domain, it requires to handle service orientation, which is today based on IP communication. And how this should work, I'd like to discuss in the further presentation. I will focus in this presentation on the automotive industry and on the software architecture provided by AUTOSAR. Okay, let's come back to data serialization. Well, this is one of the basic functions that's provided by a service-oriented communication. And the serialization is realized with a module called SUMIPEX that is located in the middleware layer of the AUTOSAR software stack. And this means it can also be used for CANXL. So that's good news, because if you adapt the AUTOSAR software layer, that's done basically in the lower layers. That means data serialization is already available.